Good morning friends. Today we are going to learn a new method, that is Newton-Raphson method to solve algebraic and transcendental equation. In the last lecture we already learned what do you mean by transcendental equation. Equation which contains trigonometric functions or logarithmic functions or exponential functions is called as transcendental equation. So now we already learned regular pulsing method to solve such equation. Now today we learn one more new method to solve this algebraic or transcendental equation. That is, we are trying to find out the roots of that equation. This is again a iterative method similar to that regular pulsing method. So we'll write here it is used to find the roots of transcendental or algebraic equation. So this is again one formula, that is xn plus 1 is equal to xn minus f of xn divided by f dash of xn. We know that in regular Fulci method, our formula was this: x1 is equal to a into f of b minus b into f of a divided by f of b minus f of a. To find the solution, as we know that this is iterative x1, x2, x3, and we require a and b as two initial values, so that the root lies between these two. So here in Newton-Raphson, we need only one initial. Here we have condition that f of a is into f of b is less than 0. That is, this product should be negative, but here no such condition is given. So here we can find the solution with the help of only one initial value. So what we'll do, now suppose you put n equal to 0 here in the above formula, what you'll get if you put n equal to 0 here? We get x1 is equal to x0, x0 you can say, minus f of x0 divided by f dash of x0. Means we are just replace this value of n by 0, so get x1, here it is 0, 0, 0. Now this is first iteration. Now similarly, when we put n is equal to 1, what we'll get? Now put n equal to 1 here, so 1 plus 0.2, so we'll get x2 here. So x2 is equal to, here what we'll get if you put n as 1, x1 minus f of x1 divided by derivative of this, that is f dash of x1, and the procedure is continue. We have to continue this procedure till the last two approximations give the same value. What is the meaning of this? The meaning of this is, I already explained in the regular falsy, but once again I will explain. Suppose x1 is 0.9437 and x2 is equal to 0.9436. Both are same? No, because 7 and 6 both are different. And in x3, if you are getting 0.9436, then we can say that last two approximations are same. That's why it is written. Continue this procedure till the last two approximations give the same value. So we got same value here, so the root of the equation is 0.9436. So with the help of this, now we will try to solve some of the problems. First example, use Newton-Raphson method to solve the following transcendental equation or function where f of x is x cube plus x minus 1 is equal to 0. Let us first try with a polynomial with the initial condition x0 as 0, because we need only one initial point. So if x0 is 0, what we'll write in solution? In solution, first let us write down f of x, which is given. F of x is given as x cube plus x plus 1, which is given. Correct. Then write down the value of f of 0. Put x is equal to 0 here. So what we get? 0 cube plus 0 minus 1, which is equal to minus 1. Then find out f of 1. When you put x as 1, you get 1 cube plus 1 minus 1 is equal to 0. Even though we know here the initial condition is x0 as not, but we are finding this f of 0 and f of 1. The reason is that if x0 is not given in the examination, then in that case we have to find out x0 with the help of this. So f of 0 is negative, f of 1 is positive, and the method is similar to that regular Falsi or secant method. Here also we are finding 2 points. So here we can find out initial value is given as x0 is equal to 0, right? Here negative positive, so you can take x0 as 0 or 1, or in some of the cases if it is not given, you can take the average of these two, that is 0 plus 1 by 2, that is 0.5 as x0. That also you can do. It will reduce the number of iteration as the value of x0 is closer to the given root. The number of iterations required to get the solutions are less. So here x naught is 0. So what will get? So f dash of x is equal to, because we need the derivative of the given function, so derivative of x cube plus x minus 1 is 3x square plus 1 plus 1. This is the derivative of given function. Now let us start with the formula. So we need your function, we need its derivative, so I have written here, and now we'll start with our Newton-Raphson method. So let us write down the formula for Newton-Raphson. So we know Newton-Raphson is xn plus 1 is equal to x suffix n minus f of xn divided by f dash of xn. Now once you get the formula, what is the first step in Newton-Raphson? Since this is the iterative method, put n is equal to 0. When you put n equal to 0 here, what will get? First iteration, put n equal to 0 and x naught equal to 0, which is given in the example itself. So x1 becomes x naught minus f of x naught divided by f dash of x naught, because we are putting n as 0. So we got this. Now substitute the value of f of x naught and f dash of x naught. So what do we get? Therefore x1 is equal to 0 minus f of x naught minus 1, because earlier we already got the value. F dash of x becomes 3 into 0 plus 1, that is minus 1 upon 1 into minus 1. So minus 1 minus 1 it becomes plus 1, so is 1. So we got x naught as 1. Again we require a function and its derivative, so I am writing for reference. So in the second iteration we will put now the value which we obtained in the first iteration. In the first iteration we obtained the value of x1 as 1. So we will put this value to get x2 now. x1 is already given. So now we have to find out x2. So how to get x2 now? So x2 is equal to, then you put n equal to 1 in our Newton-Raphson method, that is in this formula xn plus 1 is equal to xn minus f of xn upon f dash of xn. What will get? If you put n as 1, 1 plus 1 2, n as 1, so x1 minus f of x1 upon f dash of x1. And therefore this is equal to, now we can substitute the values of x1 as 1 minus f of x1 divided by 3 into 1 plus 1. F of x1, because we know that here 1 plus 1 2 minus 1 is 1, so we are putting this as 1. So now 1 minus 1 by 4. If we simplify this 3 plus 1, we get this as 4. So 1 minus 4 by 1 minus 1 by 4, that is x2 is equal to 3 by 4. So we got the value of x2, that is 0.75. So we got x1 as 1, then we got here x2 as 0.75. Now what the next step? In the third iteration, again this is for your reference because we need to find out the values. So in the third iteration, we'll put n equal to 2 and x2 is equal to 0.75 in Newton-Raphson formula. So we get x3 is equal to x2 minus f of x2 divided by f dash of x2. And now substitute the value of x2 as 0.75 here also, and here also. So what we get? So we get x3 is equal to 0.75 minus f of x2. Put here f of x2, that is 0.75 cube plus 0.75 minus 1 divided by 3 into 0.75 square plus 1. And if you simplify this, what you get? Therefore x3 is equal to 0.6860. But if you observe, x2 is 0.75, x3 is 0.6860, both are not same. So you can go for the next iteration, that is the fourth iteration. In the fourth iteration, we will get, when you put n equal to 3 and x3 is equal to 0.6860, we get x4 as x3 minus f of x3 divided by f dash of x3. We are always writing the formula in each step so that it's very simple to understand for the examiner too. Now this is equal to, now put the value of x3 is, therefore x4 is equal to 0.6860 minus f of x3, put the value of x as 0.6860 here, so 0.6860 square plus 0.6860 minus 1 divided by 3 into 0.6860 square plus 1, and therefore this is equal to, now with the help of calculation we can find out, therefore x4 is equal to, yes, calculate with the help of calculator. I will suggest you stop the video, you calculate and then cross verify the answers. Okay, so it will give you the practice. So 0.6823. Now we have 0.6823. Now we have 0.6860. Both are different, so we need one more iteration. So again, this is for reference, and therefore in the fifth iteration we'll get put n as 4 and x4 as 0.6823. Therefore x5 is equal to x4 minus f of x3 x4 divided by f dash of x4. So we get the value of the fifth iteration, and now put the value of x4 everywhere. So we get x4 is equal to, that is x5 is equal to 0.6823 minus 0.68, we are substituting the value here, 0.6823 cube plus 0.6823 minus 1 divided by 3 into 0.6823 square plus 1, and if you simplify this with the help of calculator, we get x5 is equal to 0.6823. But you observe x4 is 0.6823, x5 is also 0.6823, both are same. Therefore we can claim that, therefore root of equation is 0.6823. So this completes the solution. So in this way we have solved the example with the help of Newton-Raphson method, which is just a formula to get the solutions. In the next lecture we will solve one more example of Newton-Raphson method. Okay, thank you.